Hello, everyone. Let's talk about this LeetCode problem, divide two integers. It's actually a good problem, I think. But in LeetCode, there are a lot of some songs. It's because there are a lot of corner cases that make people very upset. For example, the corner cases are about integer maximum, integer minimum, and sometimes it will be overflow. So people get a lot of runtime errors from it, and this gives some downs. Okay, let's take a look at how to solve it elegantly. Okay, this is the problem. Given two integers, dividend and divisor, we need to divide two integers without using multiplication, division, and mode operator. Now, assume we're dealing with an environment that could only store integers within the 32-bit standard integers range. So for this problem, assume that your function returns 2 to the 31 minus 1 once division result overflows. So 1 will the division result overflow. Imagine that dividend is negative 2 to the 31. Divisor is negative 1, so we will get 2 to the 31, which is beyond the range. So for this case, we need to return integer maximum. Okay, let's take a look at this for simple examples. For the first example, 10 divided 3, we get 3. For second example, 7 divided negative 3, we get negative 2. For third example, 0 divided 1, we get 0. Note, the problem mentions that divisor will not be 0. So for the fourth example, it's 1. Okay. Assuming the dividend is 59 and divisor is 3, in order to get the result without using multiplication, division, or mode, we need to use subtract. So we can subtract 3 19 times, then we get 2, which is smaller than 3. Then we can stop, and we get the answer, 19. Okay, imagine that the dividend is 10 million, but the divisor is 2 or 3. Then you need to subtract millions of times, which is super, super slow. So how can we improve the speed? Subtract 3 is very slow, but we can subtract a larger number. For example, we can subtract 6. Each subtraction will contribute 2, right? So we just subtract 10 times, and we subtract 6 9 times. For each subtraction, we get 2 contributions, so the answer is 19. We can make it faster. We can subtract 12 first, or 24, or 46. For 46, we subtract 46, then we subtract 1 6 and 1 3. We just need to subtract 3 times, then we get the answer. So this is the core ideas of these problems. Okay, for this table, we know 3 is the base divisor. The contribution is 1. Then comes 6, contribution is 2. Then 44, 46, 48, the contribution is 16. And initially, the dividend is 59. So we can consume 48, and answer will become 16. And we still have 11. Then we try to consume 24. No, we can. 12, no, we can. 6, yes, we can. We consume 1 6. Answer will become 18. Then we can keep consuming 3. Answer is 19. Then we can just return, finish. Okay, let's see how to implement it. For the first solution, I will allow use long type in the program. I will refactor later. So in the solution 2, we will not use long. So for now, we can use long. Okay, at the very beginning, let's consider the corner cases of the overflow. If the dividend is int minimum and divisor is negative 1, we know it will be overflow. Then we can just return int maximum. Okay, next, we just decide if it's positive or negative. Okay, then I want to convert numbers to positive numbers. So we get new dividend and new divisor. Note, I need to use long here since dividend and divisor can be in minimum. If we use ABS in minimum, it can be undefined behavior. Okay, next I define power. Power is related to the contribution. For example, initially the new divisor is 3, so the contribution is 2 to 0, which is 3. For example, when new divisor becomes 12, the power is 2, so the contribution is 2 to the 2, which is 4. So in this while loop, we try to make our new divisor as large as possible, but which cannot exceed the new dividend, otherwise it's meaningless. So in this while loop, if the dividend is 59, after this while loop, the new divisor will become 48. Okay, we keep this while loop as long as power is not negative. And for my current new dividend, as long as it can consume a new divisor, we will consume it and add the contribution to our result. Then we just decrease the power, and for this operation, it's just like divide my new divisor by 2. Okay, finally, if it's positive, I return result. Otherwise, I return negative result. Okay, for this solution, we use long type here. Let's see how can we get rid of the long type. So in order to get rid of the long type, we need to make dividend or divisor not integer minimum. As long as it's not integer minimum, we will not get undefined behavior. Let's see how can we make them not integer minimum. Okay, so this is solution 2. Most of the code remains the same. One difference is here. We just declare integer instead of long. Okay, the major difference is in the gray box. Let's see, how can we make sure the dividend or divisor is not integer minimum here? Okay, if the divisor is integer minimum, then it's very easy to handle. We know only integer minimum divide integer minimum is 1. Anything else divide integer minimum is like 0 point something or negative 0 point something, so it's just 0. Okay, if the dividend is integer minimum, first we need to consider the corner cases. If the divisor is -1, we just return integer maximum. Otherwise, we try to consume one divisor first. If divisor is positive, then the result is negative. So we need to append a -1 here. Then we just consume one divisor here. Otherwise, if the divisor is negative, we know the result is positive. So we append 1 here and we consume one divisor here. So we recursively call this function. And in the recursively function, since we pre-process the dividend, so in the next call, it will not be integer minimum. Then we can simply use the ABS function here so that we get rid of the long type. Okay, that's it. That's the solution. Thanks.